A couple of years ago, running a genuinely powerful large language model at home sounded almost ridiculous. If you wanted something even remotely close to the models people were using in the cloud, you needed multiple expensive GPUs, huge amounts of memory, complicated Linux setups, and enough patience to troubleshoot everything when it inevitably broke. But that picture is changing very quickly. Today, a single consumer GPU can run models that would have looked completely unrealistic on a home PC not that long ago. And I'm not talking about tiny models that can barely answer basic questions. I'm talking about models that can write code, analyze documents, reason through problems, use tools, help with research, and in some cases, power local AI agents. So I think we're entering what I'd call the second boom of local AI. The first local AI boom was basically about one question: can I run a large language model on my own computer at all? The second one is much more interesting. Now the question is, can I run an AI that is actually good enough to replace some of the things I currently use cloud models for? And surprisingly, the answer is starting to become yes. To understand why, we need to look at what changed. Because consumer GPUs didn't suddenly gain hundreds of gigabytes of VRAM overnight. A lot of people still have 12GB, 16GB, or 24GB graphics cards. Those numbers haven't magically become unlimited. What changed is the software and the models. One of the biggest breakthroughs is quantization. Normally, large language models can store their parameters using formats like FP16 or BF16. At 16 bits per parameter, a model gets huge very quickly. A 7 billion parameter model can need around 14 gigabytes just for its weights. A 32 billion parameter model is around 64 gigabytes. A 70 billion parameter model can be somewhere around 140 gigabytes. Clearly, that's not going into a normal gaming GPU. But we don't necessarily need 16 bits for every parameter during inference. If I quantize that model down to 8 bits, the memory requirement gets roughly cut in half. Go down to 4 bits, and suddenly a 32B model might need somewhere around 16 to 20 gigabytes for its weights, depending on the quantization format. Now we're talking. A model that originally looked like it needed professional hardware can suddenly fit onto something like a 24GB consumer GPU. And this is why quantization has completely changed local AI. But quantization alone doesn't explain what's happening. The more important change is that smaller models are getting much better. A few years ago, if you wanted noticeably better AI performance, one of the easiest solutions was simply to make the model bigger. More parameters, more GPUs, more training compute. But the industry has become much better at squeezing intelligence into smaller models. Training data has improved. Post-training has improved. Reasoning techniques have improved. Distillation has improved. Model architectures have improved. And the way models are trained for coding, tool use, and instruction following has improved dramatically. So a 20B or 30B model today can sometimes feel much more useful than a Sinwilly-sized model from an earlier generation. That matters enormously for local AI. Because the difference between a 30B model and a 70B model isn't just a number on a model page. It might be the difference between fitting entirely inside my GPU and having to spill half the model into system RAM. And once the entire model fits inside VRAM, everything changes. Speed becomes much better. Latency becomes lower. The model becomes far more pleasant to interact with. And suddenly, local AI stops feeling like an experiment and starts feeling like a real tool. This is why I think 24GB GPUs have become particularly interesting. If you have 24GB of DRAM, you're sitting in a really useful part of the local AI market. Small models are obviously easy. 7B, 8B, 14B models can often run comfortably. But more importantly, with good 4-bit quantization, you can start reaching into the 20B and 30B range while still keeping the model on a single GPU. That is a huge difference. Because once I get into that size range, I'm no longer just asking the model simple questions. I can use it for coding. I can give it documents. I can use it as part of an agent. I can connect it to tools. I can run private data through it without sending everything to a cloud server. And I can leave it running all day without thinking about API costs every time it generates another 1,000 tokens. That last point is becoming increasingly important. Cloud AI is incredibly convenient. I use it too. You don't need a powerful computer. You don't need to download model files. You don't have to worry about CUDA versions, drivers, quantization formats, or VRAM. You just open a website or call an API. But cloud AI has one property that local AI can never completely ignore. Someone else owns the computer. Your prompts are being sent somewhere. Your documents are being processed somewhere. The model can change. Pricing can change. Rate limits can change. Features can disappear. And if your internet connection goes down, your AI is gone. With a local model, the relationship is completely different. The model is a file on my machine. If I download it today, I can still run that same version tomorrow. I can disconnect the internet. I can feed it private documents. I can integrate it with my own software. I can modify the system prompt however I want. I can choose exactly how much context to give it. I can even build an agent that operates entirely inside my own network. That level of control is becoming more valuable as AI becomes more deeply integrated into actual work. And that brings me to what I think is the biggest reason local AI may be entering a second boom. AI is moving from chatbots to agents. A chatbot might answer one question. An agent might call the model 50 times to complete one task. Imagine asking an AI coding agent to inspect a project, read 10 files, search for a bug, write a fix, run tests, notice that something failed, modify the code again, and then explain what it changed. That could involve a huge number of tokens. If every one of those tokens is going through a paid API, cost suddenly matters much more. But if I have a capable local model running on my own GPU, the economics become completely different. I already bought the hardware. Now the main ongoing costs are basically electricity and hardware depreciation. So for heavy workloads, especially automated workloads, local inference becomes much more attractive. There's another interesting part of this. AI models don't necessarily need to do everything themselves anymore. The model can use tools. This means a smaller local model doesn't need to memorize the entire world. If it needs current information, I can give it search access. If it needs my documents, I can use retrieval. If it needs to calculate something, I can give it a calculator. If it needs to work with code, I can give it access to a repository and a terminal. If it needs structured data, I can connect it to a database. That changes what powerful AI actually means. A smaller model with good reasoning and access to the right tools can sometimes be far more useful than a giant model running completely alone. And I think this is going to make local models much more important. Instead of asking whether my local model can beat the biggest cloud model on every benchmark, I'm asking a different question. Can this model do my task? If I want an AI that helps me search my personal documents, maybe I don't need the largest model in the world. If I want an AI coding assistant running inside my development environment, maybe a fast 20B or 30B coding model is more useful than a giant model that takes forever to generate. If I want a private assistant controlling smart home devices or working with confidential company data, local execution may actually be more important than getting the absolute highest benchmark score. This is why I wouldn't judge local AI purely by model size anymore. Efficiency is becoming just as important as intelligence. How much VRAM does it need? How fast does it generate? How long is the context window? How well does it use tools? How well does it follow instructions? How good is it at coding? How badly does quantization affect it? Those questions matter more to me than simply looking at parameter count. And there's another hardware trend helping all of this. Consumer computers are getting much more AI friendly. We now have GPUs with large amounts of fast VRAM. We have systems with large unified memory pools. CPUs are getting better vector instructions. Dedicated neural accelerators are becoming common. Software frameworks are becoming easier to install. And local model applications are becoming much more polished. Not long ago, running a model locally could mean opening a terminal, installing Python packages, fighting dependency conflicts, downloading a 100-gigabyte checkpoint, discovering it doesn't fit, then spending the next 2 hours trying to figure out why CUDA isn't working. Now, depending on what you use, it can be almost as simple as selecting a model and clicking download. That matters. Technology usually doesn't become mainstream just because it becomes possible. It becomes mainstream when it becomes easy. And local AI is getting much easier. But I also don't want to oversell this. A single GPU still has real limits. If I have a 24GB card, I'm not going to run the largest frontier models at full precision. I'm not going to reproduce a giant cloud cluster under my desk. And if I try to force an enormous 100B plus model onto my system using aggressive quantization and CPU offloading, I may technically get it running, but that doesn't mean the experience will be good. This is where people sometimes get confused. They see a video saying, I ran a 70B model on one GPU. That sounds amazing. But I want to know what that actually means. Is the whole model in VRAM? What quantization is being used? How much system RAM is involved? How many tokens per second? How long is the context? How long does the first response take? Because it loads is not the same thing as it's useful. For me, the sweet spot is usually the biggest model that still runs comfortably on the hardware, not the biggest model I can force to load. If a 32B model gives me fast responses and stays entirely inside VRAM, I may prefer it over a 70B model that needs heavy CPU offloading and generates painfully slowly. Especially if I'm building an agent. An agent might call the model again and again. 2 seconds of extra latency doesn't sound like much. Multiply it by 100 model calls and suddenly it matters. This is another reason optimization is going to become such a huge part of local AI. We're going to care more about tokens per second, more about memory bandwidth, more about KB cache efficiency, more about quantization, more about speculative decoding, more about mixture of experts models, more about architectures designed specifically to deliver more intelligence per gigabyte. The goal is no longer just making models bigger. The goal is getting more useful intelligence from the hardware we already have. And that's what makes this moment different from the first local AI wave. The first time around, running a local LLM was exciting simply because it worked. You could disconnect your internet connection, type something into your own computer, and watch an AI model answer you. That was enough. That was enough. Now expectations are much higher. I want my local AI to write real code. I want it to understand long documents. I want it to search my files. I want it to use tools. I want it to act as an agent. I want it to respond quickly. And most importantly, I want it to be good enough that I don't immediately switch back to a cloud model after 5 minutes. We're finally starting to get there. I don't think local AI is going to replace cloud AI. The biggest cloud systems will probably continue to have advantages in raw intelligence, huge context workloads, massive multimodal models, and tasks requiring enormous compute. But I also don't think the future is going to be cloud only. I think we're moving toward a hybrid world. Really difficult task? Send it to a frontier cloud model. Private document? Run it locally. Quick coding task? Local model. Huge research problem? Cloud. Background agent making hundreds of routine decisions? Maybe local. And once you start thinking about AI that way, a powerful GPU becomes something very different. It isn't just a gaming component anymore. It becomes your own AI server. A machine sitting under your desk that can generate text, write code, analyze documents, process images, run agents, and potentially automate parts of your work without sending every single request to somebody else's data center. That's why I think the second local AI boom could be much bigger than the first. The first boom proved that local AI was possible. The second one is about proving that local AI is actually useful. And that models continue getting smaller, quantization keeps improving, software gets easier, and consumer hardware keeps getting faster, the question may soon stop being, can one graphics card really run powerful AI? Yigoga. The more interesting question might be, how much AI do I actually need the cloud for anymore?